This is the fifth lecture on vectors, which is from class 12 maths exercise 10.4, and in this video is containing the solution of question number 7 to 12 of exercise 10.4, and I am starting with the question number 7. Three vectors ABC are given. This is vector A, this is vector B, and this is vector C, and you are asked to prove this LHS equal to RHS. This is actually distributive property. A cross B plus C is A cross B plus A cross C. At first I am finding the right hand side. It is A cross B plus A cross C. Cross product we know, we have learned in the previous videos. Cross product is made by determinant A cross B plus again A cross C. So A cross B, it is made by determinant in which the first row is ijk, and the second row is made by the coefficient of first vector, coefficient of A1, A2, A3, and the third row is made by coefficient of second vector is B, coefficients B1, B2, B3. Same way the second term is A cross C. It is cross product made by determinant in which the first row is ijk, and the second row is made by coefficient of first vectors A, that is A1, A2, A3. Third row is made by the coefficient of second vector C. We have here C1, C2, C3. So this is LHS. We don't have to calculate to show LHS equal to RHS. We no need to calculate find the value of the determinant. We will keep it like this, and we will see the LHS now. For LHS, we have to first find out B plus C. So B plus C, B is here, B1I, B2J, B3K, and C, C1I, C2J, C3K. So at first we have to add these two, adding corresponding terms, I, similar terms together, I with I, so it will be B1 plus C1 into I, then B2J, C2J, it will be B2 plus C2 into J, B3K plus C3K, so it will be B3 plus C3 into K. Then writing the LHS. LHS is A cross B plus C. It is also cross product between this vector and this vector, between A and B plus C. Cross product is made by determinant. First row is ijk, second row is made by the coefficient of first vectors A. Coefficient of first vector A, we have A1, A2, A3, and then the third row is made by coefficient of second vector. B plus C is a single vector now. This is B plus C. B plus C, this is the vector B plus C. Coefficients B1 plus C1, B2 plus C2, B3 plus C3. And then we have a property of determinant. Property of determinant is very simple to learn. The property we are using here is very simple. If each entry of a row or column also is sum of two, if each element of a row is sum of two entries, then this determinant can be split into two. This determinant can be split into two determinants. The first row will be same for both. The first row is same for both the determinants. Even the second row is same for both the determinants. And for the third row, the first entries of the elements of third row will come for the first determinant. All the first entry B1, B2, B3, first entry will come for the first determinant, B1, B2, B3, and each second entry will make the second determinant. Second row same. First row is same for both the determinants. Second row also is same for both the determinants. So second row will be A1, A2, A3. And the third row, each first entry making the first determinant, and all the second entry, that means C1, C2, C3 will make the second determinant, C1, C2 and C3. And we can clearly see LHS, what RHS and LHS we got are clearly equal, and we can say therefore LHS is equal to RHS is the complete proof for this question. Question number 8, it is like this. If vector A is 0, then vector B is or vector b is 0, then their cross product is a 0 vector. If a is a 0 vector, b is a 0 vector, either a or b, then cross product is 0. It is given. Cross product is a 0 vector. Now we are to ask about the converse, whether the converse will be true or not. Converse means if the cross product is 0, then will the vector a and b 0? Will vector a be 0 or vector b be 0? We are asked to say. The converse is not true, because we have learned if any two collinear vectors, if a and b are collinear or parallel, same meaning in vectors. If two vectors are parallel, then one is scalar multiple of another, some multiple, maybe twice, maybe thrice, maybe negative multiple. And whenever two vectors are parallel, then their cross product is equal to a 0 vector. So if cross product is a 0 vector, then vector a not necessary that it has to be 0, or vector b also it is not necessary that it should be a 0 vector. I can show with an example. It is not necessary that we can write the answer like this. If cross product is 0, then it is not necessary that vector a must be 0 or vector b must be 0. We can show with example two non-zero vectors in which their cross product is a 0 vector. I can take a is a vector, say I plus j plus k, and b is a scalar multiple. You see here a is lambda b, or you can take b is lambda a. B is lambda a. So I can take a vector b which is multiple of vector a. I just multiply by 2. I can say 2i, I can take it 2i, 2j, 2k. You see the vector a is non-zero, vector b is also non-zero. I am taking 2, you can take any number, 3, 4, fraction, non-zero, any non-zero number in place of lambda. So I am taking 2, and then if we find the cross product we know how to find using the determinant. First row is made by ijk, second row is made by the coefficient of first vectors 1, 1, 1, and the second vector's coefficient 2, 2, 2. And if we find this cross product, we know how to expand it. It will be 0i, 0j, 0k, which is a 0 vector, and is the complete solution. So if the cross product of two vectors is 0, then it is not necessary that the vectors must be 0. We can see here two non-zero vectors, cross product is a 0 vector. Question number 9. The question is, find the area of triangle in which the vertices ABC coordinate are given. I have written the vertices with the diagram. In the diagram I have drawn and I have written the vertices. Now the first thing is the question should be corrected. In the question it must be mentioned using vectors. Using vectors find the area of triangle with vertices given. Because there are different methods of finding area of triangle. Coordinate method is there, determinant method is there, integration method is there, and here we are going to learn vectors method. So it must be mentioned by using vectors find the area of the triangle. Now the concept is here like this: if a triangle in which two sides are represented by vectors a and b, one side is represented by vector a, another side is represented by another vector b, then at first we will find the cross product of two vectors, which we find by using determinant. Then we will find the magnitude of the cross product, sum of square of coefficients of ijk, and then the area of triangle formula is, it is half of cross product magnitude. This gives the area of triangle, half of cross product magnitude, area of triangle. Now here in this triangle the sides are not given, only the vertices are given. So at first we have to find out any two sides. I'll find AB, any two sides enough, third side is not necessary. I'll find AB, I can represent it by vector A, then AC can represent by vector B, third side is not necessary. So A vector, it is AB, and it is found like this: second minus first. It is position vector of second minus position vector of first. So what is second here? We have to see the order of writing A and B. B is second, position is 2, 3, 5. So we have to write in vectors 2i plus 3j plus 5k minus first is point A 1 1 2 1i 1j 2k, and then it is 2 minus 1 is 1i 2j and 3k. So I got vector A representing side AB, and then AC I have to find representing by vector B. The same concept, position vector of second minus position vector of first. We can write like this: position vector of second minus position vector of first. Then here C is second, 155 minus A is first, it is 112, then it is 0i 4j and 3k. So I have got the vectors A, this is vector A I got, and then vector B I have got, which are representing the two sides of triangle. And then concept we have discussed here. At first we have to find the cross product of the two vectors. A coefficients are 1 2 3, making the second row. B coefficients are 0 4 3, making the third row, and we know how to expand the determinants using first row expanding. When I then close I with row and column, the remaining is making the determinant. It is 2 3 4 3. Then same pattern for J, it is 1 3 0 3, and for K it is 1 2 0 4. And finally we are getting 6 minus 12, J into 3 minus 0, K into 4 minus 0. So it is minus 6i minus 3j plus 4k, and then we will find the magnitude. This is what we have got is the cross product of A and B, and then we will find the magnitude. A cross B, magnitude is the coefficient of I square, coefficient of J square, coefficient of K square. Magnitude is made by under square root the sum of square of coefficients, and it is 36 and 9 16, it is square root of 61. And the area of triangle, this is the formula. So area of triangle is equal to half of A cross B magnitude, it is half of square root of 61. So we can write it square units. Area is written in square units. So this is the complete solution. So the question can be given like this, in which A and B are directly given, vector A and B may be given. We can find the area of triangle. We can just find out the cross product, magnitude, and area of triangle. Now if the vertices are given, the points, coordinates of ABC, then at first you have to find out any two sides. The way we have done, one side A, it is the second minus first. Whenever 2 points, the vectors are found like this: second minus first, second minus first. And then we get the, after getting the two vectors, then only we will find the cross product, magnitude, and area of triangle is cross magnitude of half of magnitude of cross product. Question number 10. Two vectors are given, A and B, which are representing two adjacent sides of a parallelogram. Adjacent side means it is the two vectors starting from the same point. We cannot take one this side, another the parallel side, no. Adjacent side starting from the same point, A and B. Then the formula is here. Area of parallelogram is given by cross product, magnitude. So at first what we have to find? We must find out, we have to find out the cross product. Cross product we know, first row made by ijk, second row is made by coefficient of first vectors 1 minus 1 3, then the third row is made by the coefficient of second vectors 2 minus 7 and 1, and then we have first step we will find out the determinant. Expanding using the first row, which we have learned before. When finding the coefficient of I, then close I with row and column, and same pattern is followed for both J and K. It will be 1 3 2 1, and for K it is 1 minus 1 2 minus 7, and all this second order determinant we know how to find. Cross multiply this direction minus this direction. So it is I into minus 1, minus of minus is plus 21, J into 1 minus 6 plus K into minus 7 plus 2. So it is 20i minus minus of minus will be plus 5j and minus 5k. Then we have to find the magnitude of this vector. The formula is here. We have to find the magnitude of this cross product. It is under square root coefficient of I square, coefficient of j square plus coefficient of k square. So it is altogether 450, and 450 we can write twice 225. 225 is a square number, it is square of 15, so it will be 15 square root of 2. And then this is the area of triangle, area of not triangle, area of parallelogram. Area of parallelogram is just the magnitude of the cross product, which is 15 square root of 2, and then you can write it in square units. Area is always measured in square units. So this is the solution when to find the area of parallelogram in which the adjacent sides are given. And remember, if the diagonals are given, there are questions in which the diagonals of the parallelogram are given, then the area of parallelogram is half of if the diagonals are given, then diagonals I am explaining here. If the diagonals are given, then diagonals we represent by one d1 vector, another is by d2 vector, and then same way you will find the cross product d1 d2, and then you will find the magnitude, and area is given by half of d1 cross d2. Half of d1 cross d2 magnitude gives the area of parallelogram if the diagonals of the parallelogram are given. But here the sides, adjacent sides are given, then this is the solution. It is just cross product, and magnitude of cross product represents the area of the parallelogram with sides. Question number 11. Two vectors A and B in which their magnitudes are given, and it is said that A cross B is a unit vector, then what will be the angle between the vectors A and B? It is like this here. Definition of cross product, we know if two vectors A and B making an angle theta, their cross product is given by this definition. A cross B magnitude A, magnitude B, sin theta n cap. N cap is a unit vector which is perpendicular to both A and B. These things we have discussed in the past video. Now n cap is a unit vector, and hence its magnitude must be 1. Unit vector definition is a vector whose magnitude is 1 and of any direction. So here magnitude A given, magnitude B given, and two vectors we are asked to find the angle. What will be the angle we are asked to find? So since it is about cross product, so first I'll use the definition of cross product. A cross B definition is magnitude A, magnitude B, sin theta n cap. Now if I take magnitude on both sides, then magnitude of A cross B, since A cross B is a unit vector, so this magnitude also must be equal to 1. A cross B as a whole is a unit vector, it is mentioned, and any unit vector magnitude is equal to 1. Now right side, coming to right side, magnitude A is given 3, magnitude B is given square root 2 by 3 sin theta and n cap. Then I'll apply magnitude in the right side also. This is getting cancel, 1 equal to square root of 2 sin theta. When theta is an acute angle, magnitude of sin theta is sin theta only. Then n cap magnitude is 1, as we have discussed here, is also a unit vector. Then what we are getting finally? We are getting finally sin theta is 1 by square root of 2, and which is a known standard value of sin is, it is sin pi by 4. So angle theta is pi by 4. So pi by 4 is the correct answer. So if magnitude A, magnitude B given, A cross B is a unit vector, then the angle between the vector is pi by 4. If 45 degree, then only A cross B will be a unit vector. Question number 12, the last question of this exercise. Given 4 points A, B, C, D, which are the vertices of a rectangle, and you are asked to find the area of a rectangle. These are given in vector form, so obviously we are going to use vectors. And a rectangle is a parallelogram. Opposite side, parallelogram definition is opposite sides are parallelogram, so a rectangle is also a parallelogram. And for parallelogram we have the formula: if two adjacent sides A and B, adjacent sides, remember adjacent sides, the sides starting from the same point. If the two sides, adjacent sides represented by A and B, then first we will find the cross product, and then the magnitude of cross product represent the area of the parallelogram. So in this case, sides are not given, the vertices A, B, C, D are given. So we have to find out any two adjacent sides. I'll start from the point A, adjacent sides. One I'll take AB, another I'll take AD. Point C is not necessary for calculation. We'll get the, any two sides will take, adjacent sides, we'll get the same answer. So AB I'll find out, represent by A, and AD we can represent by B, and we can just find out the cross product and magnitude, which will give the area of the rectangle, because rectangle is also a parallelogram. So AB at first I am finding, it is found by second minus first, position vector of second minus position vector of first. So second minus first, I minus of minus is plus, so it is coming 2I, 1 by 2 minus 1 by 2, 0j, 0k. So this is one side, and the other side, adjacent side B is AD, again second minus first, it is coming like this, 0I minus 1j plus 0k. So we got the vectors, two adjacent sides A and B represented by vectors A and B, and then finding the cross product. At first, cross product is formed by determinant I, j and k. First row is formed by I, j, k. Second row is formed by the coefficients of vector A, which are 2, 0 and 0. Then the third row is made by second vectors 0, minus 1 and 0. Now we'll expand the determinant. If we expand, it will be I into minus j into plus k into. And if we expand first vector, first coefficient, it is going to be 0. For j also it is going to be 0. Only for the coefficient of k we will have 2, 0, 0 minus 1. So this is 0I, 0j, and we are getting minus 2k. Then the magnitude is square root of coefficient of I square, coefficient of j square, coefficient of k square. So minus 2 square is 4, which can be written as 2 square, which is equal to 2. That means the area of parallelogram, area of rectangle is just the magnitude of cross product, and it is 2 square units. So this is the complete solution for this question, and this is the end of this video, in which I have given the complete solution of exercise 10.4 question number from 7 to 12 in this video, and previous video containing question number 1 to 6 solution, which is available in the playlist. And in the next video I will give the solution of miscellaneous exercise of this chapter.